students. We commend you for your hard work, your resilience, and your achievements during your time at UCLA. You have been able to weather unexpected events in the last year of your studies, including a world-changing pandemic that we have not quite overcome, and the excruciating persistence of systemic inequalities and racism exposed by continued acts of police brutality. Given that the nature of your work is understanding our planet as an integrated living system, we know that you will lead the way in search of environmental solutions and opportunities that will benefit all members of our society. To the families and friends, thank you so much for being there for your graduates. We look forward to honor you in person. Until then, please accept my congratulations to you, the class of 2020.
I hope it was worth the wait.
Thank you, Jasper, and thank you, in absentia, Miguel. And so now it is my pleasure to introduce Dr. Roy Rasmussen, who comes to us from the National Center for Atmospheric Research. And Dr. Rasmussen got a bachelor's degree in physics and math at Wheaton College in Illinois in 1978. And then he came to UCLA and earned a master's and a PhD in 1980 and 1982, respectively. And he specialized in cloud physics. And from there, he went on to be an advanced study program postdoctoral researcher at NCAR. He is currently senior scientist at NCAR and the National Center for Atmospheric Research. And he is also director of hydrometeorology applications program at the Research Applications Laboratory, RAL, at NCAR. He is a fellow of the American Meteorological Society. He has 10 patents and over 150 journal papers. And the patents are on things like de-icing. He also works on various types of cloud physics, climate interactions, and also some on cloud seeding. These are all problems of great interest to many of the graduates, as well as of great importance to society. So I welcome and thank Dr. Rasmussen.
Well, thank you, Susan. It's a great honor for me to be here today, and even if it's virtual, I remember fondly my days back in UCLA in the late 70s and early 80s, and it was a great time of learning and meeting colleagues and friends. And something that I wanted to let the graduating class know is that everybody you meet now will continue to be colleagues throughout your career, and important colleagues. And that's something that I did not anticipate when I graduated, but remember to stay in contact and with all your friends and colleagues, and they will be with you and talking with you the rest of your careers. So I think Susan mentioned a lot of the things that I was going to mention as well, but I'll try to organize them a little bit more. I wanted to start out to say that I'm deeply grateful to the Department of Atmospheric Sciences at the time that I graduated. Since then, Oceanic has been added, which is great. At the time that I graduated, I had no idea where I would be going or what I would be doing, but I ended up at the National Center for Atmospheric Research, and that's been a fantastic opportunity for me. I've been there for many years now. I started in 1983 as a postdoc and got a permanent job there in 1989, and I've been there ever since, so about 30 years. And I'm a senior scientist and a program director. I do research on climate change, mostly related to the water cycle. My background was at UCLA, was in cloud physics. I got a PhD in cloud physics, working in in the UCLA wind tunnel. I don't even know if it exists anymore, but it was a great opportunity for me to learn basic cloud physics about clouds, and all the other classes I took have been tremendous assets as I have moved on in my career. And that is been key to the success that I have had in my scientific career. So what I would like to talk to you about today is the 5 C's to becoming a successful scientist. Now, I don't have much time, so I'm going to go pretty quickly, but Susan already mentioned some of them already. First one is consistency or grit, or Susan called it hard work. And I think that is really important. A recent book by Angela Duckworth called Grit, I think expresses it very well. And that essentially the book was her PhD. And the book essentially came up with, or her research came up with 2 equations. And I'm sure you didn't want to hear about equations in the commencement speech, but these are pretty simple. The first equation is something that Susan already alluded to, is that talent times effort equals skill. So when you came to UCLA, you had a certain amount of talent, and you applied your effort, hard work, and that hard work and talent has resulted in skill. And that's what you have today. And I would add talent times effort times education equals skill, because the education that you have gotten during your years at UCLA results in this skill. So as you go out in the world and get a job, you will take that skill with you and you'll apply effort again, and that's going to give you the achievements, papers and seminars and whatever you end up doing. The point here is that your skill is what you learn, and then you have to apply your effort to achieve papers, etc. And what I wanted to point out is that effort comes in both equations. So really the hard work and effort is squared. And so the effort really, really pays off. And I'm convinced about that in my own career as well. So is that enough? Well, I think you need to have more than just hard work to be a scientist. I think as Susan already alluded to, you have to be curious.